Here we go. Okay, so today we're going to cover 10.7. Grab my book. And maybe something else. We'll see how it goes. All right, so we're going to cover 10.7. We're going to be looking at what's called marginal analysis. So we finally get to do something that has to do with business, all right? So remember from 1324, you had three major functions that you discussed. They were the cost function, the revenue function, and then the profit function. So cost, revenue, and profit. And there was a formula for profit that involved cost and revenue, and it was that profit is actually revenue minus cost, right? So this should all look familiar to you? All right, so we're going to be talking about something called marginal analysis today, and it involves derivatives. In the last class, we learned how to take derivatives using basic shortcut rules, right? And it was a very convenient rule because it saved us quite a bit of time, didn't it, when it came to taking derivatives? And if you did the homework, you probably saw that the homework for that section was pretty straightforward. Okay, so we need to understand what marginal analysis is. When you see this word marginal, this is dead. When you see that word marginal, I want you to start thinking, as soon as you see this word, I want you to be thinking derivative. Because really, that's what this is saying. When you say marginal analysis, we are trying to take the derivative, use the derivative of a function to somehow analyze what's going on. And I thought that the best way to kind of introduce this idea was to give you a specific visual example of what's happening, okay? So I'm going to put a function up here that we're going to start working with, and it's going to be a cost function. And I made it up, so let me just make sure I use the right one. Yeah, it should be the cost. So as an example here, I'm giving you a cost function. It is 100 plus 10x and then minus 2x squared. So I made this problem up. This cost doesn't go with any specific word problem, so let's just make it up ourselves. So this is the cost of, let's say, producing. We have a company, right? And we make what? iPhones? Okay, so we'll just say we make iPhones. This is the cost of, let's say we sell iPhones. It doesn't matter. We make them, all right? So we make iPhones. This is the cost of manufacturing X number of cell phones, all right? So X is equal to the number of iPhones and C of X would then be the total cost of producing X iPhones. So let's try and understand, first of all, what this function gives us. So try and help me interpret what C of 0 would be. What does C of 0 mean in terms of, in words? Zero iPhone, but I mean, tell me in words, what is the answer to this going to be, and what's it going to mean? It would be 100, right? So if we plug 0 into this, we get 100. And what does that 100 mean? That's the cost if we don't make any phones. So we've got to pay, electric bills or something like that, right? We're going to have some cost associated with making no phones, right? Still there's a cost. This would be referred to as a fixed cost. Okay? So what about if we make one phone? How much is it going to cost us if we make one phone? So we plug 1 in here, right? And what do we get? 100 plus 10 minus what? 2. And what would that be? 108. And we made up this problem, okay? We'll just say that this is like dollars. So it costs us $100. If we don't make any phones, it's going to cost us $100. If we make one phone, it's going to cost us $108, right? Let's try another one. What about C of 2? So plug in 2, see what we get. 100 plus 10 times 2 minus 2 times 2 squared, right? So this is 100 plus 20, that's 120, and then I'm taking away, let's see, that's 4, taking away 8. So what's 120 minus 8? 112. So what I want you to pay attention to is that all we're doing here is plugging numbers into the original cost function, which is nothing special. What we want to try and pay attention to is what was the change in the cost as we went from producing one to the next. So how did our cost change as we went from 0 phones to 1 phone? We had an increase, right? The cost increased by how much? $8? I'm going to put dollar signs in front of that, right? So there was an increase of $8 to go from here to here. Now, what about increasing from 1 phone to 2 phones? It was only $4. So I'm going to put, how about an up arrow for increase? So I don't have to write increase over and over. So it went up by $4 here. Agreed? On the next step. Notice that's not the same, right? So let's try one more. Let's go to 3. What would be the cost of manufacturing 3 phones? So we have 100 plus 10 times 3 minus 2 times 3 squared, which would be, let's see, 100 plus 30 minus 9 times 2 is 18. So where are we at now? What do you got? 112 again. Yes? Y'all see that? So did we have an increase in cost? No. There was a $0 increase. Now that's kind of important because that's telling me that if I manufacture 2 phones or 3 phones, I actually have the same cost, don't I? According to this model, it makes no difference in terms of cost to manufacture 2 phones or 3 phones. Get the same thing, right? Let's go one more. I want to see what happens at 4. 100 plus 10 times 4 minus 2 times 4 squared, which equals 100 plus 40 minus, let's see, 4 squared is 16. 16 times 2 is 32. So where are we at here? What is it? 108. 108. 108. Y'all agree? So what was our change? I never put the answer here, sorry. This was 112. So what's our change? What is our change from here to here? It decreased by 4, didn't it? So this was a decrease by $4. $4. Went down by $4. So now it looks like as I produce more, my costs are starting to go down, right? You with me? this whole idea of trying to figure out what's happening as you move from one by one through these numbers of units, whatever it is, iPhones or whatever it is, this whole study of what's happening here as opposed to just the numbers, this is marginal analysis. We're trying to study how the cost is changing as opposed to what the cost is. This is the cost, right? Cost. Who cares? We want to know how it's changing. Is the cost starting to rise or is the cost starting to decline? Understand? Now, there are two ways to approach this. One way is just to do kind of what we're doing here. Notice that to get the 8, what did I do? I took 108 and I subtracted 100, right? That's how I got 8. How did I get the 4 here? I did the 112, subtract the 108, I got 4. Yes? To get 0, I did 112 minus 112. To get a decrease of 4, I did 108 minus 112, which was negative 4, right? That gave me the decrease. So that's one way to do it. And that's the exact precise way to do it. You would have to, if you want to know the cost of producing, the increase in cost in producing like the 50th item, you would have to go look at and take the difference between two, all right? But there's another way we can do it, which is approximating it, and that will be using the derivative. But let's make sure we understand this idea first. So I'm going to ask another question now. So I've got all this right here, right? Let me get the question. This is a question like what will appear in the homework. Given this cost right here, what is the exact change, and that's a key word here, change in cost of producing the 8th iPhone? Let's be very clear on what this question is asking. It is not asking how much it costs to produce 8 iPhones, right? It is not asking how much it costs to produce 8 iPhones. It's asking how much is my cost going to change if I produce that 8th iPhone, right? How much is it going to go up by, my cost? So it wants me to do like a subtraction like this, right? So how am I going to be able to figure that out? What am I going to need to know in order to figure out the change? Man, that's terrible. If I want to know the cost of producing the 8th iPhone, what do you think I'm going to need to know? Cost of producing the 7th. Yes, exactly. We need to know the cost of producing the 7th, right? And we also need, man, that is like a terrible marker. Wow. So let's see if this makes sense to you. I should probably move this marker very far away from me. All right, so let's see if this makes sense to you. In order to find the exact change in cost at the 8th iPhone, what we need to do is we need to calculate the cost of the 8th iPhone minus the cost of the 7th iPhone. Right? That's what we need to do. So that's like me going down that list I had, going to the 7th and the 8th one, and then subtracting the two answers, right? That's it. So that means we want to do, this will be equal to 8 plugged into this. So let me just do that in parentheses. I'm going to do 100 plus 10 times 8 minus 2 times 8 squared. Right? That's the cost of producing 8. And then minus, I'm not going to have enough room here, the cost of producing the 7th, which is 100 plus 10 times 7 minus 2 times 7 squared. Are y'all all with me? Okay, I'm going to get my calculator out because it's probably going to go a little faster if I have my calculator. There it is. Maybe not. It looks dead. I always carry a backup. Let's see see if it's dead. Nope. Okay, good. All right, so anyone that has their calculator, feel free to spiel out an answer here if you get it. I'm getting 52 for this one. 52. And then I'm subtracting from that. Notice I put this cost of the 7th phone. Notice I put the whole thing in parentheses, right? Because I'm going to subtract it when I'm done. So I get 100 plus 70. Getting 72. So I get negative 20. Does anyone else get negative 20 that tried it? Yes? Okay. What does this mean?
That the cost increases.
The cost is decreasing, right? It said, what is the exact change in cost of producing the 8th iPhone? Well, the exact change in cost is that my cost is going to decrease by $20. Okay? That's it. So I would say cost will decrease by $20. So I notice I'm not putting negative 20. The negative is coming from the fact that I said decrease as opposed to increase. All right? So now let me give you kind of a more general formula. All right? This is if I wanted the exact change in cost of producing the 8th one. But what about this? If I was trying to come up with a formula, what is the exact cost of producing X plus 1 units? Now, I did that on purpose. I did X plus 1. I did it because that's what the book does, all right? So think about this. We wanted to know the 8th item, right? Just a second ago, we want to know the cost of producing that 8th item. And to do that, we had to do the 8th item, the cost of the 8th item minus the cost of the 7th item. So if I want to know the cost of the X plus 1 item, what am I going to need to do? Calculate. To do this, I need to do the cost of something minus the cost of something else. What is it? Cost of the X plus 1 one. That was like the 8th one, right? And then I'm going to subtract from that the cost of the X one, which would be the one right before it. All right? Now, this is the way the book does it, and that's fine. You could have, instead of using X plus 1 here, you could have said X here. And then this formula would have changed to C of X minus C of X minus 1. So it's kind of like, if you're going to do the 8th one, then you'll do the 8th one minus the 7th one. Does that one make more sense, the one in black, than the one in blue? But the one in blue is the one that they are using. Okay, so if this is 8, right, that's 8, then this is 1 less than that, isn't it? So this would be 7. I hope that makes sense. But that's the formula in the book. So if they ask us, what is the exact, did I forget change in here? Oops. Change. I forgot to put change. Change in cost. What is the exact change in cost of producing X plus 1 units? Then we'll use this formula. So what if they wanted us to find the exact cost of the exact change in cost of producing the 500th iPhone? We would do what? They wanted us to do the 500th. You plug 500 in, and then minus, you plug in $4.99. Okay, and then subtract the 2, and you would get your answer. Is that all right? You sure? Okay, now let's try and take a look at what's going on here visually, because right now we have done nothing with derivatives, right? Nothing at all. Everything we've done has been just purely an algebraic approach, you could have done this in 1324. We haven't gained much, right? All right, so let's take a look at this picture. I slapped this together before class. Like I was sitting in my office at like 9 o'clock trying to pound this out on my computer. So I came up with this little animation for you. Let's see how this goes. Let me try and make this a little bit larger, see if... Okay, so you see the red curve? This red curve is the function that I just gave you. 100 plus 10x minus 2x squared. All right, so the red curve is the cost function. Now I want you to look at, I have two different lines on this curve, and I'm going to bring this over here. Where are we? 7. There we go. Okay, let's take a look at this one. So you see these two lines, the red one, the dark red and the green. Can you all see those okay? Let's look first at the green one. The green one is the exact cost of producing the x plus 1 item. So if I look at my x-axis, I'm here at 8, right? We said 8. So what we do is we go up. This point right here is the value of the function at 8. This is c of 8, right? And then if I go back one more unit to 7, and I go up, I get this point, don't I? And if I calculate c of x plus 1 minus c of x, that's what we had to calculate, right? I want you to see that this is actually rise over run of this green line. If I ask you to go from, to give me the slope of the line between these two, right? What you would say is it's the change in the y coordinates, right? Which should be this, right? That's your change in y coordinates over the change in x coordinates. But what's the change in x coordinate? It's 1, isn't it? It's 1. So this is over 1. So isn't this the slope of the secant line? Isn't that the slope of that secant line? Do y'all see that? Sure? Yeah. Y'all are just being agreeable? That's the green one is the slope of the secant line, and the answer to that is negative 20, and that's what we got, right? But instead of that, I would like for you to look at the slope of the tangent line. So go back here to 7, okay? Go back here to 7, and I want you to see if you went up to 7 and you took the slope of that tangent line, what is the slope of this tangent line according to my calculation? Negative 18, right? Now these are not the same answer, are they? They're not the same. But do you agree that it's a pretty good approximation? Like it's a pretty good approximation of what's happening. Because this tangent line is always going to be pretty darn close to that secant line as I move through the graph. So what we can do in business with business models is if we have a function that gives us cost and we'd like to know something about how what our change in cost is, what we can do is instead of looking at this computation, we can actually look at the derivative instead. So we are going to now look at the slope of the red one as opposed to the slope of the green one. But the green one's the exact answer, the red one's an approximation. Understand the difference? Are y'all sure? Let me move it around. Let me back this thing up. Because there's some really kind of interesting things happening. Like look at there. The exact cost, negative 8. Our approximation is negative 6. You see they're kind of pretty far off there, aren't they? That's why it's an approximation. All right. I hope you get the idea visually of what's going on here. So let me formalize this. I'm going to put this up as a definition for you, and then we'll do some more examples. All right. So we have the marginal cost. The marginal cost, by definition, is c prime of x. Okay, that's what it is. It's the derivative of the cost function. That's all it is. That's why I told you, look, when you see marginal, think derivative. So if someone says, hey, I'd like for you to talk about the marginal cost function, you're going to just take the derivative of the cost function. That's the definition of it. You also have marginal revenue. And what do you think the marginal revenue function is? Just the derivative of the revenue. And then finally you have marginal what? Profit. Is the derivative of the profit function. So again, the key word here, marginal meaning derivative. Now I'm going to give you a theorem. Theorems in math are things that have been proven to be true. And this gives us the relationship between marginal and exact change. And it's pretty much what I told you just a second ago. It says this: the marginal cost function is a good approximation. So we use a squiggly equals to mean approximate. All right? The marginal cost function at x is a good approximation of the exact change in your cost function, going from x to x plus 1 items. Isn't that exactly what I just tried to show you with that picture? It's approximately. Sometimes it's dead on, but sometimes it's off a little bit. And this goes for all three of these functions. So you could have, or the marginal revenue function is approximately the revenue at x plus 1 minus the revenue at x. And finally, the marginal profit function is approximately the profit at x plus 1 minus the profit at x. All right, I think we're ready to do like an example that would be something like you would see on a test and something you would see out of the book for homework. All right, and I don't think I'm going to need the projector anymore. Question? Yeah?
Oh, just making sure that was it.
That's an R.
Okay.
Does that look like something else?
I just.
It is an R. All right. So let's do an example. How about this one? We have, try and give you kind of a nasty one. Okay, so how about this? We have a profit function which is given to us to be 22x minus 0.2x squared minus 400. And I have two questions for you. First one, part A. Want to find exact profit of selling the 51st unit. Now, we didn't talk about what we were selling. Do y'all care or no? The problem in the book says we're selling calendars. Who buys calendars anymore, right? My wife did actually the other day, but she got one it was like at Walmart on sale. It was like 50 cents. She brought it home and it was a 2017 calendar. I was like, that's why it was 50 cents. All right, so find the exact profit of selling the 51st unit. All right, that's the first question. Second question, what is the marginal cost of selling so I put cost, profit, sorry. Marginal profit of selling the 51st unit. Yeah. All right, so I'm going to kill the light, or turn on the lights and turn off the projector. It's a little too sleepy in here with that on. Oh, I forgot to press the damn button. Okay, hopefully that doesn't mess up the video too much. Okay, so what is the first one going to be? How do we do the first part, part A? Plug in 51 into what? Into the profit function, and then do what? Subtract from that what? 50 plugged into the profit function. So to do this, see, when they say find the exact profit, right? And look at the wording, find the exact profit of selling the 51st item. So they're telling you in the wording, I mean, I'm reading it exactly the way it says here. Find the exact profit from the sale of the, well, they used 41st, but I'm going to do 51st calendar. So we're trying to figure out what is the exact profit from the sale of that 51st one. It's not saying how much do you profit by selling 51 calendars. Can you see that in the wording, because it's a little tricky? Okay. So we want to do here the profit at 51 minus the profit at what? 50. Okay? Now before we do it, can you tell me what we need to do here? For that one? Marginal profit means that we're going to be approximating the answer to part A by using the derivative, right? So we want the derivative of the profit function, but where? What do we want to plug into the derivative? I put the formula up here just a second ago. I said this, p prime of x, is approximately equal to p of x plus 1 minus p of x. Isn't that what I wrote? So if I'm going to be trying to find this right here, right, I can approximate that with what? P prime of, is it 51 or 50? That's what I'm trying to get at. So look, what's this one right here is x, that's x, right? This is x plus 1. So I actually need to do 50 in the derivative. That can be the part where people mess up, because everything in the question is talking about 51, right? But when you go to find the marginal profit, you actually have to go kind of back one. And what we're doing is, think again about that tangent line. If we're trying to figure out what's happening at 51, right, how much it's growing by, then we go back to 50, and we try and find the slope of the tangent line there to project out where we're going to be. That's what we're doing. All right, well, let's do the first computation, and we'll probably need our calculators for that. So we're going to plug in P of 51. So I would recommend that you bring your calculators and actually go through these computations with me in class, so that way you know that you're not trying it for the first time on the test, like sitting there with your calculator and not knowing how to work it. Does anybody have anything for P of 51 yet? Just that first piece. 201.8. Good. 201.8. Minus, now we're going to do the same thing but with 50. If you're not getting 201.8, then you need to get with me or something to figure out what's going on. How about for 50? Anyone get that one yet? 200. All right, so when we subtract the 2, you get 1.8, don't you? 1.8. And I believe this was, it tells you in the problem that it was in dollars. So what does this mean? How can I interpret this answer, 1.8? What's my interpretation of this answer? Profit is increasing. Increases at a rate of $1.80 per unit. So at exactly that moment that you go from the 50th calendar to the 51st calendar, your profit is going up by $1.80. Okay? Now let's do part B. So for part B, we need to take the derivative of this, don't we? Okay, that's from last class. So let's go ahead and take the derivative. What is P prime of X? So don't tell me. Everybody take out a sheet of paper, put your name on it, write the derivative of it down, and pass it forward. I'm going to take that as a quiz grade. And work by yourself. I want to make sure that you know how to take a derivative now. This is, in my mind, this is like a gimme quiz. This is like a free 100 here. And if you don't see it the same way, then we're not on the same page, all right? You should be able to take the derivative of that right now. Be quick, be quick. All I want is for you on a separate piece of paper to write down the derivative of that function and then hand it forward. That's it. Just the derivative. I don't want you plugging in 50 or anything. Just give me the derivative. It's like a pop quiz. I'll let you use your notes, but I'm only giving you like another 50 seconds to finish this. And do your own work. If you have it, you can bring it up, or just raise your hand. I can take it. Yeah, fold it in half. I like that. Or tear it in half. You good? Make sure your name's on it. Thank you. Going to pass the sign-in sheet around also. Finish the quiz first, then get that thing going. 30 seconds. Thank you. Yeah. Thank you. Okay, I need what you have, please. Or unless you want to not turn something in. right, that's it. Anyone else? Last call.
Trying to get the trailers up.
Don't worry about it. Yeah, don't worry about it. Okay. All right. Don't worry about those. That's fine. Make sure your name's on it. Okay, that's it. Okay, so look. I hope that went okay. I have a bad feeling about it, but let's go ahead and go through it. So what is the derivative of 22x? Just 22. Constant is attached to a function, so the constant comes down. And the derivative of x is just 1. All right, so that's just 22. Now here you have another constant, negative 0.2. But now you need to take derivative of x squared. So the 2 is going to come out front. So this is going to be times 2. And then what happens to the power on that x? Comes down to 1. So I can just go x to the first power, just x. Then I have minus the derivative of 400, which is 0, because derivative of a constant by itself is 0. So we get this. And if I just clean that up, I get 22 minus. Now you have to multiply these two together. That just gives you 0.4. X. So that is the derivative. That's all I wanted. This, yeah, no, it's just, this is me just showing, oh, you mean the 0 in front of here? Or this is 0. No, this is just me being clear on the fact that the derivative of 400 is 0. You don't need to write it. Okay, that's, I would expect everybody in this class to be able to do this with relative ease at this point. All right? So there's our derivative, right? Now we just plug 50 in. If we plug 50 in, we're going to get our approximate answer. I'm curious to know how close it's going to be to 180, or 1.8. Let's see. So if we plug in into this, it's going to be 22 minus 0.4 times 50, which gives you what is this? 20? Hold on. Is that right?
Yeah, 20.
Is it really that big of a difference?
I got 2.
2, I was going to say.
Oh, well, yeah, it's 22 minus 20.
Yeah, oh, okay. I'm sorry. I thought you were saying something. All right. It's 22 minus 20. There you go. All right. And that's going to be 2. Well, $1.80, $2, right? We're off a little bit. Now, the idea here is that if somebody wants you to find this exact, profit, the change in your profit, if they want you to look at multiple places, you have to keep doing this computation over and over, right? As opposed to this, you have a formula for it, don't you? And now I can just start plugging in values and figure it out. In fact, I could even graph this, couldn't I? Like graph it as a function. What would that be if I graphed it? It would be a straight line. It would actually have a y-intercept where? Where would the y-intercept of that line be? 22. And it would have a slope that's negative, right? So it would go like this. So just by looking at that, I would know that as x changes, my change in profit is actually getting smaller and smaller and smaller. But that we'll talk more about that later. We're just trying to get these first computations done. This okay? You sure? Do you need another example of this, or do you think you could handle that? How do y'all feel? Please, not all at one time. Raise your hand. I don't like you talking over each other. Are y'all comfortable or not? Because I'm ready to move on to a little bit something a little different. Okay. All right, so if somebody gives you a cost function, a profit function, or a revenue function, they ask you for the exact rate of change, you're going to do that computation. If they ask you for the marginal, you're going to take a derivative and plug in, right? Just be careful with you have to go back one number, right? You have to go back one number when you do the derivative. All right. Let's talk about something different, a little different. Marginal. You know what? No, let's not do marginal. Sorry. Let's talk about average cost, average revenue, and average profit. This is actually a pretty useful idea. So let's see if you can keep up with this. Let's say, just as something for you to think about, I give you a table right here real quick of something. This is going to be the number of iPhones we sell. And this is going to be our profit. Okay, I'm just going to make up some information here. If we sell 0 iPhones, we're going to have 0 profit. Okay? If we sell 1 iPhone, we're going to have a profit of $30. And let's just say this is in dollars. If we sell 2, we're going to have a profit of 40. If we sell 3, we're going to have a profit of 45. 4, it's going to jump up to 52. Okay, so we've got this. You get the idea? The number of phones that we're selling and what our profit is. Yes? Now we want to talk about this thing called average cost or revenue or profit. So what was my total profit? If I sold 4 phones, what's my total profit? $52, right? What is my average profit per phone? So how much did I make? 52, how many phones did I sell? 4, right? So if I take 52 and divide it by 4, what is that? 13, right? I get 13. That means I made $13 per phone. Yes? How about right here? When I sold 2 phones, what was my average profit here? It was 20. So if I take 40 divided by 2, I get 20. So if you're looking at your average profit per phone or per unit, it's the total profit divided by what? The number of phones you sell, right? And you can tell here I had a better average profit per unit than I had here, right? So average cost, average revenue, average profit, the way you calculate these is as follows. You take the cost function and you divide it by X. That's how many units you made. For the average revenue, you take your revenue function and you divide it by the number of units you sold. For profit, same thing. You take your profit function and divide it by the number of units you sold. That's kind of what I was doing here. Take the profit, divide it by the number of units I sold. With me? Now there's a special notation for these 3. That's why I left a little bit of a gap out in front of them. This average cost function, you write C with the bar over it and then X. This one you write R with a bar over it and then X. And here you write P with a bar over it and X. I don't know if you've ever seen this. Anyone ever take a statistics class? If you have, then X bar means average, the average of the X values. So that bar is pretty commonly used in mathematics to mean average. So this is when you see that bar, it means average cost function, which is your cost function divided by X, average revenue function, average profit function. With me? Okay, now, what do you think the marginal average cost function is? What do you think the marginal average cost function is? Well, do you know what the average cost function is? That's it right there, right? Do you know what marginal means? The derivative, right? So this is C bar prime of X. So we actually have to be able to take the derivative of whatever this is in order to find the marginal average cost. And then these follow the same way. If you take this, I do this, I keep on doing this in all the homework videos I've done. I keep on doing that, which is a vector in a calculus class, and I'm sorry, I just keep doing it. So if you see me do that and I don't correct myself, just let me know. All right, so this is prime R, and then this last one is your P bar prime of X. So if you want to think about a summary of what we have today, we have a total now of 12 functions. We have cost, revenue, profit, derivative of cost, derivative of revenue, derivative of profit. Okay, those are the marginal. And then you have average cost, average revenue, average profit, and then the derivatives of average cost, derivative of average revenue, derivative of average profit. So that's a total of 6 functions, right? 6 here, 6 there, sorry, 12, right? I already said 12. What I meant is that's a total of 6 derivatives, right? Okay, so let's see if we can handle the problem I started class with in terms of average cost. So we started out with this model. I showed you the picture of it. It was this function c of x equals, I believe it was 100 plus 10x minus 2x squared. Remember that one? I said that was our cost function. Yeah? Now, what's the average cost function? That's the first thing I'm going to ask you. What is the average cost function? So what is it? I take that whole thing and divide it by x. That's it, right? So the average cost function is this up here divided by x, right? Part B. What is the marginal cost function? What is the marginal cost function? Tell me in words what it is or what I need to do here. Take what? Take my marker.
By the average.
This one? And? Oh, like the derivative of this? Okay, careful. Read this carefully.
Oh, you didn't put average?
I didn't put average, and that's intentional because I wanted to make sure you're seeing the difference. What? Okay, so it's the derivative of this one, right? So we have to understand the language because the word problems, when you see them, they're not going to just tell you like, hey, find c prime of x. They're going to say, what is the marginal cost function? So you need to realize, okay, I need to look at the cost function, right? That's the cost function, and I need to do the marginal cost, which means the derivative of that. So I need to take the derivative of capital C, which is, we never did this one, but what is the derivative of capital C? 10 minus 4x. Good. So derivative of 100 is 0. Derivative of 10x is 10. Here the 2 pops out. That becomes minus 4x. Now part C. What is the marginal average cost function? Okay, so you see the difference in the wording on part C and part B. I threw in the word average. So now we're going back to the average cost function. We're finding the marginal average cost, which means we need the derivative of this. So we need to find the derivative, right, of C bar. And that means I need to take derivative of this, don't I? And that's a little bit of a problem. Because this was easy to do because I just did each one by one. But this is a big fraction, isn't it? And we haven't talked about how to take derivatives of this yet. We're going to use a rule. It's going to be called the quotient rule, but we're not there yet. So could I somehow get around the quotient rule here? I could split this into 3 separate fractions because they're all over x, aren't they? So I could do 100 over x, 10x over x, and negative 2x squared over x, right? So watch what I'm going to do here. Just watch the way I write this. I would like to take the derivative of the average cost function. So that means I want to take the derivative with x being my variable. So remember the notation last class? This meant I'm going to take the derivative of something. And I'm trying to take the derivative of 100 over x plus 10x over x minus 2x squared over x. All I've done is split this up into 3 separate pieces, that's a legal move algebraically. We talked about that last class, that you can do that. Now, I still am not ready to take the derivative, so I'm going to write d dx again, and just help me clean this up. How am I going to rewrite 100 over x? 100x to the negative 1. So remember, if the x is down here, we want to bring it up. Now, how about this one? Cancels out the x's, and I just have plus 10. And then over here, what happens? One of the x's cancels, so I'm just minus 2x. And now I would like to take the derivative of this. I can handle this now because I've got 3 separate pieces. I don't have fractions anymore like this. Everything's written out nice and clean, powers of x, so I can use my power rule from last class. So I need more room, so I'm going to come over here. What is the derivative? So this is equal to no more derivative. I'm ready. What's the derivative here? So what happens with that negative 1 out there? Comes out front, and doesn't that make that a negative 100? Then x to what power? Negative 2, because you're going to subtract 1 from negative 1. So that becomes negative 2. Okay, what about this one? What's derivative of 10? 0, so I can completely ignore it. And then derivative of this, just minus 2. That's it. Now that answer might look messy because of that negative 2, but just remember, all this means is negative 100 over x squared minus 2.
Would you accept either one of those?
I would, what do you mean? What do you mean? Like either one of those?
Yeah.
Yes. Later on, you're going to be wanting to plug numbers into this. So I just want to make sure, like if I asked you to plug in x is 10, like that you understand that this would really mean this. And that might be a little bit easier for you to compute. But I would take either one of these if that's all I was asking for. Okay. 10:30, I have 15 minutes. Did the sign-in sheet get around to everybody? So for the remaining 15 minutes, I'd like to get to the next section, or not the next section, but the, where's the calendar? Let me see. Let me just see what it says here. We're supposed to do 11:3. Yeah, 11:3 today. So I haven't started 11:3. This was 10:7. But I covered more in 10:7 than I initially had planned on. So it's actually good. Because what we were supposed to do, if you look at the calendar, we were supposed to do 10.5, which we did. That was the power rule derivative. Then we were supposed to do 10.7. Then we're supposed to do 11.3, and then go back to 10.7. So do more problems out of this section. What I've done is I've prepared us for all of these problems, and all I'm missing now is the 11.3. So I'm going to now